Using this information, we can now determine how to allocate space for our dataset. We can specify the desired value in tracks, cylinders, blocks, as well as the number of records in bytes. Despite the ability to specify these values in a variety of ways, the use of tracks and cylinders is still pervasive and quite common. Another issue is how do we determine how big to make our dataset? Well, first we have to establish how large our individual records are. This will be provided as the definition of input records you may be set to process, or it may be the result of your own design. For our example, let's assume that we have designed a record that is 100 bytes in length. We can let the system calculate the most efficient block size when we define the file, but to estimate the size, we can assume that we will use 2 fixed blocks of data per track. Since each track is 56,664 bytes, then dividing that in half gives us 2 blocks of 28,332. Since our records are each 100 bytes long, then the block size must be an even multiple of 100, so a block would be 28,300 bytes. This means we can record 283 records per block and 566 records per track. So depending on how many records we anticipate our system will receive, we can estimate how large the dataset needs to be. For example, this might represent an input file received from another system, and the typical size may be 50,000 records per day. Note that we could reuse this file daily. From this, we could calculate the 50,000 records divided by 566 records per track, and we would require a data set then of 88.3 tracks. We could convert that to cylinders by dividing 88.3 by 15 tracks per cylinder and rounding up to 6 cylinders for our space requirement. However, the process of assigning space also provides for the uncertainty in such estimates, so that a secondary space allocation can be specified, which allows the data set to dynamically expand in the event the initial estimate was too low. Excess allocation can also be reclaimed by automated storage administration scheduled routines. Names that are assigned to datasets are governed by standards established by individual organizations. The names themselves consist of a maximum of 8-byte qualifiers, each separated by a period with a maximum name length of 44 bytes. The first level is referred to as the high-level qualifier and is often used to secure access to datasets, as well as by storage administrators to control the management requirements of such datasets. In this example, we can see how such dataset names would be coded, so that sys1 and prod are both high-level qualifiers for the datasets being defined, resulting in sys1.linklib and prod.payroll.database.